Welcome to the next video in the series showing the various DeepView tools for the Raspberry Pi. In a previous video, we saw how to use the model converter to take a TensorFlow model and convert it to DeepView RT for running on the Raspberry Pi. And in this one, we'll show you how you can profile the model and get detailed layer timing information. To do that, we use our Netron-based tool. So this is a tool based on the open source Netron project, which has been extended to add the ability to do runtime profiling by actually running the models and collecting layer by layer information, as well as, of course, adding support for the DeepView model format. Go ahead and open up the model that we previously created, which is the MobileNet V2 the 1.0 at 224 by 224 resolution. We can see that the model requires 6 megabytes of runtime memory and has 1,002 labels. Now, to do the profiling, we'll need to start the model runner service on our Raspberry Pi. So we'll go ahead and SSH into our Raspberry Pi that's sitting next to the laptop here. And start the model runner service. And now back in the tool, we can select our target management. And we can see by default our local PC is added, and we've already gone ahead and added the Raspberry Pi. So we're not too worried about the PC, so we can turn that off from profiling, and it'll profile just the Raspberry Pi. So now we can begin profiling, and what this will do is it'll take the model, upload it to the Raspberry Pi over the model runner HTTP service, and then it'll run, in this case, 10 inferences, and then collect the average timing from those results and report them back into the user interface here. So now that this is complete, it'll update with the timing information. By clicking the input node, we get the overall model properties. So again, we see the description from before, but now the inference time is added. So in this case, 55 milliseconds. You'll note this is quicker than the 70 to 90 millisecond, which was seen in the previous example. This is using Model Runner, where it's able to just run the model in profiling mode with nothing else running. So there's no GUI or camera. So this gives a more ideal time. This can also be run against a live application, which is running with full camera and UI as well. Now, to inspect the layer timing information, we can go and enable the show timing parameter here. And now each layer will have been extended with the timing information for the specific host, showing the absolute time in milliseconds, as well as the percentage that the time represents for the overall model evaluation. The color coding is based on that scaling. So we can see that this layer, which takes about 2% of the overall time, is in green, whereas the 4 and 5% are in brighter yellow to orange, and finally the 7% in red. Now this is a fairly large model, so if we zoom out, you can see quite a bit of it, and we can go find other areas where the model timing is showing up in red. When we click the node, the timing information also shows up over here. Now you note we disabled the PC at the start. You can add any number of targets and all their times will show up here. So when profiling's run, it'll deploy the model to every target that you've added and accumulate all their timing information here, which is useful for comparing timing between targets. Under the node view here, you'll also get a new line for each host that you've added. The only real limitation there is the practicality of having many hosts listed. So that concludes this video. In a future video, we'll go dig into the details of the profiling and see how certain models behave better than others on DeepView RT and how to gain some insights to optimize your own models using this information. Thank you.